and welcome to another episode of SCFGLive, Science Club for Girls Live. I'm Hannah with Science Club for Girls, and that was Mr. Music with your theme song. Awesome. So great to see you again, Mr. Music. Glad you could join us. Now, as you know, science is always more fun when we do it with friends. So not only am I glad that you are all here at home watching, but I'm also glad that our good friend Nimisha is here to join us as well. So let's bring her in.
Hi, Hannah.
Hey, Nimisha, how's it going?
Good. How about you? I'm so excited to tell you about what happened during this week off.
Oh my gosh, please tell me, because it has been a whole 2 weeks since last episode. So something cool must have happened.
Definitely. Science is always cool, so it's always happening around us. Well, so I saw so many phase changes around my house during this week off. And I even drank some ice water, and the solid ice, it melted into my liquid water, and I saw that phase change from a solid to a liquid.
Oh, that's so, so cool. I was actually doing something similar. I was drinking a cup of coffee, and it was actually iced coffee, and there was some ice cubes in it, which are solids. But because I poured hot coffee over those ice cubes started to melt and became a liquid. Another example of a phase change. Pretty cool.
That's so cool.
Do you mind telling us a little bit more about what we did 2 weeks ago? Because it's been so long and I need a quick reminder.
Yeah, definitely. Well, I remember that we focused on heat and how adding heat to different objects affects the objects itself and those molecules that all these objects are made up of. And then in our first experiment, we painted these ice sculptures. And then, do you remember how you and I noticed that our ice sculptures, they kind of started turning into like watery soup?
Watery soup? Ugh, sounds kind of gross, but it's really true. And it was kind of colorful watery soup, which was kind of even cooler. And not only that, but we actually were able to sometimes speed up that phase change that we had by using a hairdryer. I remember you did that, Nimisha, and it was pretty cool.
Yeah. Well, so I had a question. So the molecules of the solid ice, I get that they changed to become other molecules, but did they change to become like this watery liquid, like the molecules in the watery liquid, or what was happening over there?
Great question, Nimisha. Well, we learned that adding heat will actually change the speed of molecule movement and their spacing. We saw that solids like ice have molecules that are pretty close together and move pretty slowly. Nimisha, why don't you try representing molecules with your hands, and let's try representing solid molecules. So those are close together and they move pretty slowly. But when we add heat, those molecules start to speed up a little bit so our hands can move a little faster and they get a little bit farther apart. And what's even cooler is if we continue to add heat and make them really, really hot, they'll speed up even more and spread out even more, turning into a, Nimisha, do you remember what a liquid turns into when you keep adding heat?
I think it's a gas?
That's right. So we have solid, then liquid, and then gas. Those are all examples of phases of matter and phase changes as we go from one to another.
Wow, that's really awesome. And I see that, I feel like we're a big fan of heat, which is kind of ironic. Like a fan keeps us cool.
Oh, that was so good. You're so good with the jokes always. I agree. I'm definitely a big heat fan.
Yeah. Well, I think that maybe we should do some sort of experiment.
Ooh, I think that's a great idea. In fact, actually, last episode got me thinking a little bit more about heat and this concept of like heat moving from one place to another. Because I know when I go upstairs sometimes in a building, it's actually hotter upstairs than it is downstairs. And I've always wondered why that is. And I also was thinking about last week when we added heat to our ice sculpture from our hairdryer, like how that worked. And we even did another experiment last time too. Do you mind telling us more about that?
Yeah, well, so in our experiment, we saw that the heat, it moved from our warm air to our cold ice cubes, and then the heat traveled from one place to another object, which was what we're going to talk about in a little while, a little bit more. But so I remember that we poured these, the liquid in our two jars. We had one jar that we covered right here, like we can see, and then we had another jar that we didn't cover. And then I remember that we used the same similar thing as we did in our first experiment with our hair dryer. We used another source of heat and we used the sunlight, and we left these out in the sun, these two jars, one that was uncovered and one that was covered. And then a couple days later, which we sped up the process a little bit on our show, but we saw that some of it evaporated and it turned into that gas, and some of the liquid came out of the jar that was uncovered because this heat source helped the liquid in the uncovered jar. Slowly, these molecules started moving faster and faster, and so the liquid started kind of like draining and turned into gas.
Super, super cool. Well, today, actually, we're going to talk a little bit more about this concept of heat transfer and how heat moves from one thing to another, like the sun to our water. Now, there are three different versions of heat transfer. There's conduction, there's convection, and there's radiation. Now, here's a cool story that will kind of get you thinking about heat transfer. So actually, yesterday, I was super, super hungry, and I went to go make a pot of mac and cheese, which is like my favorite food. I don't know about you, Nimisha, but it's so tasty. So I went to go make this pot of mac and cheese. The water was boiling on the stove. I had the pasta in my other hand, and I went to go reach for the pasta handle, and it was so hot that I immediately jumped back. I tripped over like something on the ground, and the pasta spilled everywhere, and it was insane.
Oh really my gosh.
I know.
That is quite a story.
Yeah, I know. And even better, don't worry, I didn't burn myself too bad, but that was a good example of heat transfer because the heat from the pot's handle transferred to my hand when I made direct contact with it. And that's an example of something called conduction, which we're actually going to talk about pretty soon. Today, though, there's two other types, like I said. There's conduction, there's convection, and there's radiation. But today, we're going to talk about convection because it's my favorite. Now, convection is the movement of heat energy through moving liquids or gases. And it's kind of hard to explain and visualize. So I thought, why don't we do an experiment? Nimisha, does that sound good?
That sounds great. I love experiments.
Amazing. Now, for this experiment, you're going to need a few things. You're going to need an ice cube tray, some water, some food coloring, and a clear drinking glass or jar. All right, Nimisha, tell us what we do first.
All right. Well, first we're going to mix the water that we have right here. And we're going to mix the food coloring in it. And then we're going to mix it all together. So for right now, this experiment works also a little bit better if the water, the food coloring is a little bit darker, because then we'll be able to see the effects a little more. So if you can, try to use a food coloring that's a little darker, maybe like blue. That's what I'm going to use. So
good idea. I put like 4 drops of red, so it's pretty red in mine.
Oh, wow. Yeah. Okay. Well, so like you showed us, we kind of have our colored ice cubes a little earlier here, just so we had them prepared. So what we're going to do is we're going to fill our glass of water with some warm water. So let's take our warm water and let's fill our glass right maybe above the top. All right. So in a moment, we're going to add an ice cube to the glass of water, these colored ice cubes that we have. Okay. But before that, obviously, we have to make a prediction.
Good point. And I'm here to make our prediction. So let's see. If we put cold ice into warm water, well, there's definitely a difference of temperature there because water's warm and ice is cold. So let's think, what's going to happen? Well, it's kind of actually reminding me, Nimisha, of my coffee example. When I poured that warm coffee onto my cold ice cubes, I saw them melt. So I'm wondering if we're going to have some melting happening.
Oh, well, that's a really great prediction. You're really using all the science that we've learned to make a prediction. That's awesome, Hannah. Well, I think it's going to be fun to check it out. So let's see if your prediction was correct.
Let's see.
All righty, let's drop 1 ice cube in.
Oh, I'm so excited. I like the bright blue color that you chose too, Nimisha.
Oh, thank you. All righty, here we go. Just 1. I think maybe we'll wait. Maybe we'll even
take a little bit of time too.
Yeah, I think it'll take a little bit of time. You know what's funny, Hannah? I'm even seeing some phase changes right now in my tray because it's kind of room temperature.
Very.
So I'm seeing some water kind of above my ice.
Very cool. Actually, Nimisha, I'm just remembering something kind of cool. And I'm remembering something that's related to our episode with Tamar, where different temperature liquids actually have different densities. So I'm wondering if knowing the cold ice, like this cold water, has a higher density, maybe something's going to happen. Maybe it's going to like sink to the bottom. I don't know.
Ooh, that's a great observation.
We'll have to see.
Yeah. Wow.
Do you see anything happening in your cup yet?
I do. And let me show all of. So my ice cube I noticed two things. 1, my ice cube's really, really, really tiny. Can you even see it?
Oh my gosh. No, it's so hard to see even.
Yeah. And then my water is looking kind of like blue.
Ooh, that's kind of cool.
Yeah.
Very interesting. I do see some of the blue at the bottom of your glass too, which is making me think maybe that colder water being more dense is sinking to the bottom.
Definitely.
Interesting. That's super, super cool. And I'm also thinking now, maybe when the water gets to the bottom, it probably will start to warm up a little bit. And once it starts to warm up a little bit, that might make it a little bit less dense. And just like we learned in Tamar's episode, less dense liquids, where do they tend to be in our glass, Nimisha?
Less dense liquids. Do they sing?
No, I don't think.
No. Yeah, I think they rise.
I think so. And maybe when it gets back up to the top, it might cool down a little bit more, becoming more dense and sink back to the bottom. We might get this kind of like circular motion. I don't know.
Yeah.
Very cool. Well, that's actually called something called a convection current. And convection currents are really, really neat in that they create this kind of circular motion. And not only are they in our glass right now, but we see convection currents in our everyday life. Here are some cool examples of convection currents.
Wow, that's so cool. I love that visual.
I know. Here's some other examples too. Lava lamps are great examples of convection currents, and boiling water on a stove. You might have seen, if you ever put water on a stove, the water becomes really active and lots of motion. And I always have wondered, what's causing that motion? Well, it's this change in temperature and therefore change in density that's causing this water to move and move and move. And even more cool, and more importantly, actually, is we do see convection currents in our very own ocean, which is why the ocean sometimes looks like it's dancing.
Wow, that's so cool. Have you ever had a lava lamp before, Hannah?
I have, and it was amazing. I sat there and watched it all day.
That's
It was
awesome.
incredible.
Wow,
Yep.
that's awesome. Well,
Have
this
you
is
ever-
I have never, no. But I've seen them and they look pretty cool.
They are very fun.
Yeah. Well, they look pretty cool, and I think our experiment looked pretty cool too, and pretty since it
I
was
know.
all blue.
I'll definitely have to try it with my red liquid later.
Definitely. Well, Hannah, I actually kind of have a special surprise for you.
What? I love surprises. What is it?
Well, for our next experiment, we're going to bring in someone from our very own Science Club for Girls community. It's Olivia.
Oh my gosh, can we bring her in?
Yeah,
Okay,
sure.
let's bring her in.
Oh,
Olivia!
hey everyone. Thanks for inviting me to your episode. I'm really excited to be here, and I'm going to show you a cool experiment.
I love experiments. I love them. And also, just so you know, Olivia, whenever we do an experiment, we always make observations and make predictions. So make sure to pause and have us make a prediction, because it's my favorite part and I love it, before you do the experiment. But I'm so excited.
Yeah, of course. Okay. Hold on.
What are we going to need?
Oh yeah, for today's experiment, we're going to need 2 identical bottles. Can you guys see?
Wait,
Yeah.
we have very similar bottles. I was going to say we have the same bottles, but very similar. They're so small and cute.
Yeah, they are. I think. Okay, wait. Yeah, so they have to be clear like this.
Cool.
They could be soda bottles or glass. And you're going to need warm water, cold water, food coloring,
Okay.
and a playing card or a thin piece of cardboard or anything sturdy that can hold water.
Awesome.
Yeah.
Got it all
Okay.
here.
Okay, so first you add food coloring to your bottles. I'm going to add, one of these bottles would be like cold and the other would be warm.
Okay.
And I'm going to add blue to my cold.
How many drops, Olivia?
I think like 1 or 2.
Cool. All right. I added, you said blue to the cold, right? That's what I
Yeah.
did. Cool. And what about for the warm? Does it matter?
Red for the warm.
So I have a little ring on top of my bottle for my warm water, and it's red. It's how ironic. And I'm going to put red food coloring on it.
It's a very good reminder.
Okay, and now I'm going to put cold water on in the blue bottle
Okay.
so that it turns blue.
Do we fill the whole thing up?
Yeah, it's best to fill the whole thing up.
Ooh.
And then warm water.
Warm water in the other one, right?
Yeah.
Awesome.
Okay, so now you have like 2 bottles.
Alrighty.
Yeah, so the experiment is that we're going to put the blue cold water bottle on top of the warm red water.
Wait,
And
how
we're gonna
are
see
we
what
doing that?
Oh, okay. We're going to use the plank card.
Oh, that sounds super cool.
Yeah.
Okay, is this the time to make a prediction?
Yeah.
I'm really excited. Okay. Well, what do you guys think is going to happen when we put the cold water bottle on top of the warm water bottle?
Wow. we just saw how cold water sank to the bottom because it was more dense than that warm water that we just used in our previous experiment. So I think that the cold water for our blue, I think that it's going to sink to the bottom, and then our red, which is our warm water, I think it might float to the top when we kind of combine these.
That's a good prediction, because cold water is more dense than warm water, meaning it's going to want to go to the bottom.
Yeah.
Maybe they'll like switch places.
Ooh.
And maybe there'll be some color mixing. What do red and blue make when you mix them together?
We're wearing the color.
It's purple! Like my favorite color. Okay.
Yeah.
All right, Olivia, I'm ready for this part now. This part is a little tricky. So if you're doing this at home, definitely ask for an adult to be nearby, or do what Olivia's doing and put your bottles in a tray.
Yeah, or like newspaper or anything.
Cool.
Okay, so I'm going to be really careful about this.
All right, so holding it on. Oh boy.
I'm gonna flip it upside down.
I'm getting a little bit of leakage, but that's okay. Okay.
And then I'm going to carefully put it on top of the warm water. And then, should we all pull it out at the same time?
Yep, ready?
Okay.
3, 2, 1.
Whoa!
Whoa! Oh my gosh.
Oh my gosh.
Look at this. It's going immediately into the warm water. Wait, Olivia, yours has totally changed colors.
The whole thing is purple. I think it's a bit more blue at the top, but it's still changing. It's getting darker as you go.
Oh, I can totally see the blue traveling down through my red right now. So cool. Hey guys, I have a question. What do you think would happen if we switch the order of the bottles? So if we put the cold bottle on the bottom and the warm bottle on the top.
Well, the cold water is already super dense and more dense than the warm water, as we saw. So it should probably stay the same, wouldn't it?
Yeah. I don't think it would want to switch places, right? Because the cold water, just like you said, Olivia, is already on the bottom where it wants to be, and the warm water is already on the top where it wants to be.
Yeah, and that would be really cool to see like the colors still separating even after meeting.
Really? Yeah, that would be really neat. I'm definitely going to try that after this episode for sure. Well, this was really cool. And Olivia, I'm so glad you could come on today to show us this awesome experiment and show us another example of convection in action, that transferring of heat from the warm water to the cold water. Really, really cool. Well, this has been an awesome episode. And I hope you can come again, Olivia. And Nimisha, as always, it's been great. Thank you to everyone for watching at home. This was another episode of SCFGLive. Our theme song, Olivia.
Yeah. Thanks, you.
We'll see you next time. Oh, my teeth are purple.